Hi everyone, welcome back to the session 2 of the current MLOps basic series that we have been running. Currently, we are covering the MLOps basic from the blogs of Raviraja Ganta. In the current sessions, we are learning about the basic project setup. And in the last session, if you haven't attended, I recommend you to check that particular session and come back to this particular session. In the last session, we discussed about how do we get the data, process the data, and then define the data loaders. In this particular session, we are going to learn how do we declare the model in PyTorch Lightning, then how do we train that particular model. After we have trained that model, how do we load and do the inference on that particular model. In this particularly, we were using the PyTorch Lightning since it automates a lot of engineering things that we have to do and it's a wrapper on top of PyTorch. The dataset that we were using for this thing was a Cola dataset. And in this particularly, we are doing a binary classification with two classes. The first class was acceptable, grammatically correct sentences, and second was simply grammatically not correct or unacceptable. So we understood till here in the last session. In the current session, we will be exploring how do we build a model using the Lightning module. As what we have in PyTorch, the nn.module, in Lightning, we have Lightning module. In Lightning module, there are certain uh, methods that we will be using. First is like the initialization in it for initializations, then forward for the forward passes, the training for the training step in where we calculate the loss calculation and or any other metrics, then the validation step for validation things. Test is optional. We generally do and a lot of monitoring or production grade things. However, in this particular example, we'll keep this thing as a optional. And the last configure optimizers is it is to define the optimizers that we have. Generally, we take Atom optimizer, and there are a lot of other functions that could be there. There are n number of functions. Please do check the documentation for any other method. So beginning with the code for this thing, like first, we are making the class for this particular model, Cola model, in which we are taking the PyTorch Lightning module. Here in the initialization, we are specifying the model that we are going to use is BERT uncase from the Google. And in BERT, we are defining, we are taking the model from pre-trained model that we have in the model name. We have passed here Google BERT uncased. And in this weight, we are saying like we will take the linear, we will do linear of BERT config of hidden size and these are dimensions. Then particularly in number of classes, we are seeing the number of classes that we'll have is 2. So now after this, we are defining the forward pass. In forward pass, what we are doing is we are saying like input IDs we have and the attention masks we have. So now we will pass all these parameters that we have into our BERT model that we have, and from that we will extract the outputs. From the outputs that we had from the outputs from the last instance state, we will take the HCLS, and from HCL for HCLS we'll multiply those things, adjust those things by the weights that we have to get the final logits. Now in the training step, what we'll do is like we will do the forward pass. We will do the forward pass in which we will provide the IDs and the attention masks. Like that two will divide everything by the batches. And once we do forward pass, we will get the logits, and from logits and the exact labels for those particular data, we'll calculate the cross entropy loss. And we will also log the cross entropy loss and show the progress. Then finally, in the validation step, we are doing the same as what we are doing in the training step. That is, we are calculating logits. That is, we are doing forward pass on input IDs and attention mask. And then from the loss, we will calculate the cross entropy loss. And we are also going to calculate the predictions. In predictions, what we are doing is we are taking the max of logits, like converting these the logits that we have into probabilities predictions, and then from predictions we will be calculating the validation accuracy. In this, we are doing the we are comparing batch label versus prediction, and from that we'll calculate the accuracy score, and also then we are converting that validation accuracy that we got into a tensor. Then we will log these things into the logs, and then finally do the configure optimizer where we are configuring the Adam optimizer. Once you have made the model class, now it's time to train the model. For training in the PyTorch Lightning, we are using the trainer. So this trainer makes our life very easy by orchestrating data loading, gradient calculation, optimizer, logic, logging, and a lot of other things. So if we see for the training, first we are loading the data module, then we are loading the doing model initialization, and then running the training. In training, so one of the very good advantages of PyTorch Lightning versus basic PyTorch is that if in PyTorch you are training things on CPUs and then training things on GPUs, we do have to make a lot of changes in our code. However, if you're using PyTorch Lightning, the Lightning just makes our life much more easier by easily helping us to mention the different trainers the different GPUs or CPUs that we can use very easily. So in this, there's one parameter by the name fast run. And let me tell you, it's one of the very good functionalities built in PyTorch Lightning. What it does is, uh, in in a lot of machine learning models, deep learning models, what happens is when we run the training, it runs for a couple of hours to a couple of days or maybe months in some cases. And a lot of times when we are building the model, we do not know if the model is spitting out the right, is doing everything correctly and spitting out the right output. So what fast dev run help us to do is it will run one batch of training step and one batch of validation step and then give us the output. In case if there are any mistakes happening in the validation step, it helps us right away instead of waiting for the whole process to be completed. Then logging is very important part if you're building production grade applications. And to get logs, it's like very easy there. Here we mentioned the what's the root directory of the logs, and then we are using logger board using the TensorBoard logger that we have. If you do not know about TensorBoard, like I will recommend you to go to the TensorBoard and see. TensorBoard is kind of a very good visualization functionality built inside of generally it's was built earlier for TensorBoard, but as in PyTorch also we can use the functionality of TensorBoard. And then once you just enter TensorBoard log directory followed by the log directory, you'll just see all the experiments that you have run, the results of those experiments and logs in a very easy to visualize manner. You can also do the same by using the localhost 6006 port. And there's one more thing like callback. Callback, here we are using callback for doing the model checkpoint. A lot of times the final model that you get won't be as good as the one of the sub models that we have in not so optimal state. And for that we can use something such as callback. What it does is it saves all the checkpoints of the model in some particular folder. And for example, in early, you can also do early stopping if, for example, your validation loss is not decreasing. You just wait for 3 iterations. If it doesn't decrease, you just say like, please stop the process here. It's like the early stop, the model checkpoint. And then finally, once we have built the model class, loaded the model, trained the model, then what do we do of the model? We do the inference. So in inferences, we generally, the process goes about, we load the train model, then get the runtime input, then convert the input into required format, and finally get the predictions. So here in the Cola predictor, what we are doing is first we are doing initialization, in which we are mentioning the model part, that we have the model that we loading the model from the checkpoint, and then doing phasing that particular model, and then from in processor we are loading the data loader that we have, and in this we are defining the softmax layer that we have, and finally the labels that we have would be acceptable or unacceptable. Then we define, once we have loaded everything, then we define the prediction method that we have, in which we are passing the text, and finally output of it should be the predictions. And this is what we are doing. Inference sample, we are passing it as a dictionary, in which the sentence we are giving an input as text, and then we are tokenizing data from this thing and getting a process input. Now the process input, we are converting that thing as a tensor. The the attention mask that we have and the input IDs and passing to a model that we have. Here model is the Cola model that we have load from checkpoint, and then from once we pass the input to the model, we'll get logits. For logits, then we'll apply the softmax layer, and then finally we'll get the scores. Now based on scores, we'll get the predictions, the label and the score, and then finally we'll return the predictions. So I hope in this particular session we now have completed our inference, and I hope you really liked and enjoyed whatever I explained. In the next session, we will be going through the model performance with weights and biases. Thank you everyone for joining this session. And please do mention in case if you your reviews about the session, or in case if you like or something that I should have added in the session. Thank you.